Over the next several minutes, I'm going to try to explain to you the main differences between Flybar and Flybarless helicopters. So we're here today to pretty much explain to you the main differences between a Flybar and a Flybarless helicopter. The good news, changing gears here a little bit, is that we now have really good microphones. We bought some high-end Audio-Technica unidirectional and omnidirectional microphones. We actually spent quite a bit of money on them, so I apologize if you guys had any complaints about our audio during previous episodes. That's certainly not going to be the case. We're actually pretty happy with the new equipment we just bought. So let's talk about Flybar and Flybarless. I have my T-Rex 250 here to demonstrate a little bit. I'm not going to go into details about the reasons why RC helicopters require some sort of stabilization system. But pretty much all remote control helicopters need to have something to stabilize their rotor head. And obviously we're using Flybar and paddles to do the task. Flybar model, pretty simple, yet somewhat complicated mechanical setup, I guess you could say. A Flybarless helicopter obviously does not have a flybar, does not have paddles. So now all the steering mechanism, collective, cyclic, it's all taken care of by the actual blades themselves. So we're basically removing the flybar, the paddles, and we're creating a very unstable, inherently unstable helicopter. Then we throw in a Flybarless unit and we stabilize the model by means of a gyroscope. So, you know, really different systems altogether. They feel different in the air. One has a lot of advantages over the other. The other has a lot of advantages over the other as well. So there's really no right or wrong. They're very different. But I'm not going to go into detail about the types of Flybarless systems that are out there. As you guys know, Align just released the brand new 3G is what they call a Flybarless system. But there's a lot of others out there. Mikado makes one, Skookum is another one, Gyrobot, I believe, Axiom. I mean, there's plenty of them out on the market. Curtis is releasing the Total G. Again, I'm not going to go into detail about these systems. Bobby and I will have another episode in the future where we're going to go in depth about Flybarless systems, and we're going to take all 45 minutes on a long episode to talk about them and explain how to set them up and all this kind of stuff. But for purposes of this short episode, I'm just going to tell you and show you what, in my opinion, are the main differences between both. So hopefully this will kind of give you an idea and maybe perhaps help you make your decision to go ahead and jump into Flybarless, or perhaps stay with your Flybar helicopter. So we're going to go over mechanical differences, first of all, setup differences, and as well as how both feel in flight, and what you need to look for if you were to get a Flybarless machine. So, all right, I hope you guys enjoy. Okay, here's my T-Rex 700 Flybar, and you know, as you can see, obviously you guys are more than likely familiar with the Flybar helicopter, but a lot going on up here in the head. You know, you're above your swash, you have your mixing, your washout arms with your washout base, your seesaw, your mixing arms, your Flybar cage, of course Flybar paddles, and your small and your short and long pitch lengths, as well as your washout lengths to your Flybar cage. So a lot going on, and everything needs to be obviously set up at a perfect 90 degree angle, starting from the servo to your bell crank up to your swash, and then up to your washout arms and your mixing arms. So quite an elaborate mechanical setup there. It takes quite a bit to to get one of these models flying correctly, of course. As far as stabilization, Flybar is stabilizing the rotor head in flight, and it's dampening a lot of the forces. So as you're flying, by the time these forces reach the swash plate is, I guess you could say, relaxed. So hence you don't really need top of the line servos. You know, we always recommend that you have the best servos possible, but the truth of the matter is any servo that has good centering, a moderate amount of torque, and decent speed will be suitable for any Flybar helicopter. You don't really need to go, unless you want to, but you really don't need to go with like super fast servos with ridiculous amounts of torque. And you know, anything around 100 ounces of torque generally works well on a 90 size model. So another thing about the Flybar helicopter is, for the most part, ideally we want blades that are heavier at the root than at the tip. In other words, the CG on the blades should be slightly heavier at the root, and what that does is that basically makes the blades, I guess you could say, lighter, allowing the engine not to bog as much when you're flying and doing hard 3D maneuvers and stuff like that. Another thing about the Flybar helicopter is that you don't have any of this electronics to set up. The setup from an electronic standpoint is quite easy. It's obviously very elaborate when it comes to setting up the head and making sure that your geometry is correct. And once you start flying it, you're going to notice, for the most part, some interactions that are due to everything that's going on up here on the head, and you have to work those interactions out with your endpoint adjustments, or if you're flying a Futaba high-end radio, you would use your swash mix for that. Okay, this is my T-Rex 700 Flybarless, and as you can see on this Flybarless helicopter, a lot more simple head. The setup on the head is quite a bit easy. Obviously you still need to center your servos and your bell cranks and make sure your swash plate is centered, but as you move up from the swash plate, all you have to do is make sure your driver is aligned at 90-degree angle, and that's it, and you're good to go. So this makes this repairs very, very easy. Every time you crash your Flybarless helicopter, you know you can put it back together, at least mechanically, in no time. Don't have to worry about aligning paddles or any of that kind of stuff. So that's definitely a huge advantage there. Another thing to keep in mind with the Flybarless model is the blades that you want for it are completely should be weighted totally different than the blades that you fly on your Flybar helicopter. On a Flybarless helicopter, we actually want blades that are heavier at the tip than at the root. And that's because this is such an inherently unstable system right here that we try to do everything possible to stabilize it, to kind of help the gyro do its work. Also, blades that are a little bit heavier, leading edge heavier, are also better. So the CG on the blade should be slightly different, chord-wise as well as span-wise. One disadvantage here is you definitely need to have high-end servos, fast servos, a lot of torque, and good centering. The reason for that is that there's several reasons, but one of them being the gyro is constantly working to make corrections in flight, and you really need to have a fast servo with a lot of torque to keep up with that. Another reason for the requirement to have good high-end servos is because now that you don't have a Flybar, everything transfers very easily from the blades down to the swash onto your servos. So you no longer have that nice Flybar paddles stabilizing everything at the top. You're stabilizing things at the servo level. So everything is transferring very easy down to the servo. So you do need very good servos there. And also, if you ever have any kind of mishap, make sure you double check your servo horns, your servo wheels, because they strip very, very easily. As you can see, the forces transfer very easily down from the blade grip to the servo horns. So, so quite a few advantages and disadvantages. Of course, the mechanical setup is simple, but you do have to deal with the electronics, and you have to go through your setup. As I stated earlier, I'm not going to go over the actual electronic setup of a Flybarless model. But you know, all the units are different. Mikado is totally different from Align, from Skookum, and all those. Excuse me. Some of them you use a computer interface to set it up. Some of them you just push a couple of buttons, like the Align here. On others, you have some sort of device transmitter box that you take to the field and you plug it into your Flybarless unit to configure it. So a little bit more elaborate setup when it comes to the electronics, but a lot more simple setup when it comes to the mechanical side of the helicopter. Vibrations on a Flybarless model. You do need to make sure that your helicopter is vibration free, because as your gyro sensor for your Flybarless unit picks up the vibrations, then what happens is your servos are going to move very erratically and they're going to jitter, and that can potentially burn the servo motor or cause other problems. Of course, Flybar helicopters are susceptible to vibrations as well, but not as bad as a Flybarless helicopter. So that's really something that needs to be kept in mind at all times. Again, you know, a lot of advantages. When you crash, you put it back together. There's one huge advantage here is that this helicopter is going to fly exactly the same every time. In other words, you don't have to deal with the tendencies that you see with a Flybar helicopter, where you have to use your swash mix or your endpoints on the radio to work out bad tendencies or interactions. Every time I crash this helicopter, I put it back together and I know it's going to fly exactly like it flew before. And it's not going to need any trim. It's not going to need any, like I said, endpoint adjustments or anything like that. If I punch it straight, wide open, full collective out of a straight and level hover, I know it's going to climb perfectly straight up every single time. So that's another advantage there on the Flybarless helicopter, which is quite cool. It's really a nice thing to have, that you don't have to worry about fixing interactions on the helicopter. Okay, now we're going to go ahead and go to the flying field, and I'm going to go ahead and fly my T-Rex 700 Flybar and show you a couple of things typical of a Flybar helicopter. And I'm going to go ahead and land, take my T-Rex 700 Flybarless, and do the same thing. Pretty much kind of give you an idea as to what the main differences are in flight on both systems here. Okay, I have my T-Rex 700 Flybar model here, and you guys obviously have flown a Flybar machine before, so there's really no need to go into detail as to what the Flybar machine behavior is. First thing is, when you take off on a Flybar machine, it's a real simple procedure. I mean, you notice that the helicopter wants to kind of tilt to the left due to the torque, and you feed a little bit of right aileron. So a little bit of right aileron and take off. It's typical behavior of Flybar. You get a pretty good positive feel when you're on the ground about to take off. Next thing is you got to trim them. So if the helicopter is pulling to the right or the left, you got to add your trim. This one's pulling forward, so I'm going to add a little bit of back trim. Perfect. The other thing about Flybar machines is interaction. If I punch this machine wide open, it's climbing pretty straight with no corrections. But for the most part, you will notice a little bit of interaction on a Flybar model. So you have to kind of work that out. Same with an upside down climb. You know, usually what I do is I put it in a hover, nose in, punch it wide open. This one is pulling a little bit back. So there is some interaction typically on Flybar machines that you have to kind of work out and figure it out. You use your endpoint adjustments to get rid of that. Aside from that, you know, the Flybar machine, in my opinion, has a very positive feel to it. When you fly it and you do 3D, especially on the deck, everything feels like you're completely connected to it. When you move the sticks, it just reacts right there immediately. You know, you can, for example, do crack very aggressively on a Flybar machine. Now, when you go big with a Flybar machine, it's when you start noticing all the interactions. So you have to kind of like work around to keep the machine where you want it. Something as simple as a big loop, you have to correct around the loop constantly to make sure that the loop looks symmetrical that the helicopter is not pulling in one direction or another, that you're entering the loop exactly where you want it, you're exiting exactly where you want it. So it does take a little bit of work when you fly a Flybar machine to make it look where you're in complete control and you're placing the machine exactly where you want it. Power on a Flybar machine nowadays is excellent because motors nowadays have so much power that it's really not a problem. But they certainly have a little bit less power than a Flybarless machine. And of course, auto performance is pretty reasonable too, depending on the type of blades you use. Especially on a Flybar machine, the ideal blades to have are blades that are weighted closer to the root, preferably, because that lessens the load on the motor and makes the machine a little bit more reactive. Whereas on a Flybarless machine, you want blades that are actually weighted heavier at the tip to help with stability. So again, in my opinion, very positive feel on a Flybar machine, very responsive, does really good crack, flies awesome on the deck. Big maneuvers require a little bit more work. You simply have to be on top of it as you execute the big maneuvers to make sure that you're flying through your interactions and the Flybar tendencies. All right, guys, I have my T-Rex 700 Flybarless here. First thing with the Flybarless model, that needs to let the blades get in track here. First thing with a Flybarless model is the takeoff is a little funny. I'm not going to go really into detail as to why, but basically you want to get your head speed up and just get the helicopter off the ground without hesitation. Here's where we're going to start talking about the advantages of Flybarless. First thing is this model is hovering all by itself. No trim required. Very little drift with my hand off. So you really do not have to trim a Flybarless model. Big advantage there. Second thing is no need for interaction checks or adjusting your endpoint adjustments to work out interactions. If I punch this model wide open, full collective, here we go. Hands off. Climb straight up. The same applies with any movement that you do. Upside down, it really doesn't matter. If I get this helicopter inverted and I get it pretty straight and level and I punch it wide open, full negative, here we go. Take my hand off, perfectly straight. There's no interaction. So that's another advantage. So you know that when you're done fixing a crash, you don't have to worry about the fix and making sure everything's perfect, because you know it's going to fly exactly like it flew before. That's definitely one huge advantage. Another advantage of Flybarless is the power that you're getting because you don't have a flybar. For example, just TikToks like these are completely effortless, especially if you don't have your collective management skills mastered. It really, really shines at this. It's like you gain an extra 10, 15, 20% more power. You can do like real power demanding maneuvers and the helicopter sounds as if it's still hovering almost. It's really wild. In my opinion, when I do maneuvers on the deck, I do feel a little bit of sense of disconnect. That's just me, and I think that has a lot to do with the fact that I learned to fly with the Flybar machine, and I've developed my muscle memory reactions around a Flybar. So I'm used to making corrections when I don't have to, and I'm used to expecting certain behaviors that I don't see with this. But nonetheless, it's definitely a very, I guess you could say, straight, positive feel overall. Another thing, advantage of the Flybarless model is big maneuvers are easy because, again, it doesn't have any weird tendencies that are induced by the Flybars. So when you do like big flying, big loops and stuff like that, it's almost like you don't have to do much to correct. You just provide the input and you let the helicopter do the rest. It's almost like when you fly the simulator. Big loops, like I was doing earlier with the Flybar machine, you just point it, pull out the elevator, and it stays exactly where you tell it to stay. Very little effort. I mean, if you look at my right hand, my right thumb, I'm not doing anything. It's just flying through the loop, just a little bit of back elevator. Another advantage of Flybarless is the speed. These models can pick up crazy speeds due to the less drag. I mean, I can just come in like really fast and pull, 80 to 90 miles an hour with ease, whereas it takes a lot more effort to do that with the Flybar machine, without any doubt. Finally, the auto performance of a Flybarless machine is way better too. I'm just gonna do a regular right side up auto, and I'm gonna slow down the blades and show you guys. And the thing is, you hear the blades slow down almost to a stop. You feed a little negative and they spool back up really quickly. There they go. Same deal, slow them down again and then spooling back up. It's really easy. Oops, another bouncy auto. These are examples that you really don't want to do when there's no wind. But so those are the major, I guess you could say, differences. As you can tell, the Flybarless machine has a lot of advantages. If I go ahead and do a TikTok, for example, and then I punch wide open full negative, I can take my hands off the transmitter and it'll go perfectly straight. I'll show you here. Hands off completely. It just keeps going in the same direction. So definitely a lot of advantages here. I think it'll help new pilots learn quicker, especially because they don't have to work through a lot of the corrections. So it occurred to me that I could go out there and ask random people what they think. Simply ask them a question. What do you prefer, Flybar, Flybarless, and why? And let them answer and see what they have to say. So I happened to be at the club meeting for the Orlando Remote Control Helicopter Society in Orlando, Florida. And at the end of the meeting, I just grabbed my camera and I started asking questions around the table. So we're going to see what these guys had to say. We're here at the end of the Torches meeting in Orlando, Florida. We're asking a couple of people. Quan, what do you prefer, Flybar or Flybarless?
Flybarless.
Why?
Very simple to set up and very simple to fly, and I like it.
Nice. About somebody else. Oh, look at this guy over here. Flybar or Flybarless?
Just kind of depends on what day.
You have to decide which one.
Flybar,
Why?
because I know how to fly it.
What about you, man? Flybar, Flybarless?
Flybarless. I just
Why?
like just how it holds. I like the holding, everything.
Nice, nice. Who else? Carrie, Flybar, Flybarless?
Flybar, baby.
Why?
It's simple.
Oh, because you can't fly Flybarless in FAI. You cheater. Who else? Flybar, Flybarless?
Flybar.
See, there's a lot of Flybar guys. No more Flybarless guys around here. All right, this is it for our Flybar versus Flybarless short episode of SmackTalk RC. I hope you guys found these tips useful. Some people out there are saying, oh, well, Bert hates Flybarless. This is absolutely not true. What happens pretty much with me is the fact that I learned to fly with the Flybar, and I've developed my muscle memory and my skills around a Flybar feel. So I'm so used to correcting for Flybar interactions that when I take a Flybarless helicopter, it just really feels kind of weird to me. It feels totally different. So, but I'm getting used to it now, and I can certainly see all the advantages that Flybarless has over Flybar. So I hope again that these tips were useful to you and that you can make your decision whether it is to make a conversion and change your machine around and get rid of your Flybar, or whether it is to just keep it as it is and continue to fly your Flybar helicopter. So again, I hope you enjoyed, and I'll see you next time.